Hey guys, Travis here. I didn't get a chance to push the record button in class after school today, so here I am, true to my word. I said that I would upload a video of this, and we're gonna do this again, and we're gonna upload this video. All right. I hope you guys are happy, and here we go. Here we go. Let me just blow my nose real quick. Maybe I'll edit that out a little bit. I need to remind myself to edit that. Okay. All right. Here we go. Let R be the region enclosed by the graph of g of x, negative 2 plus 3 cosine of pi over 2x, and h of x equals 6 minus 2x minus 1 squared. The y-axis, the vertical line x equals 2, as shown in the figure to the right. So this one up here, that has to be the h of x. You can see that one kind of looks parabolic. And then you can see this one right here is your sinusoid, so that's your cosine, so that's your g of x. And it says, the first thing it says, find the area of R. Well, the area of R, it's upper minus lower, so I'm going to go integral from 0 to 2, and the upper curve is h of x, and my lower curve is g of x. And if this were a calculator question, I would leave it alone, and I would just type it on my calculator, but this is no calculator. See, FRQ 5. So here we go. Integral 2 to 0, and h of x is this guy, so 6 minus 2, parenthesis, x minus 1, close it, squared, minus, open parenthesis, negative 2 plus 3 cosine of pi over 2x, close dx. So there it is. I'm going to go ahead and distribute this negative, guys. So when you do that, here's what you get. Integral. So that turns into a positive 2, and 6 plus 2 is 8. So 8, 0 to 2. And then that positive 3 cosine pi over 2x turns into a negative. So I'm going to write this one first. So I'm going to write, let's see, minus 2 x minus 1, close it, squared, minus 3 cosine pi over 2, and x on the side, close, and I think we're good, dx. If you want to put parentheses like this, you can if you want. All right, here we go. Antiderivative, I don't see any issues. Let me make sure. 6 plus 2 is 8. Yeah, that's where that 8 came from. 6 plus 2, guys. This 6 right here, and this 2 right here, when you distribute that, it'll be a plus 2. All right, here we go. Antiderivative, 8x. And then leave this alone right here. I guess if you wanted to, you could expand it, but leave it alone. They're being nice to you. Have a nice linear x minus 1 inside the parentheses here. Add 1 to that exponent. So minus 2 parentheses x minus 1, close it to the third power. That's a power 3. And then divide by 3. So there it is. That takes care of that guy. And then the antiderivative of cosine is sine. So you're going to keep the sine. Minus 3. I'm going to leave some space. We're going to turn that to sine of pi over 2x. And so because we're taking an antiderivative, if we were taking derivative, you would multiply by pi over 2. But because we're taking antiderivative, you got to multiply by the reciprocal of whatever's in front of that x. 2 over pi. And there it is. It's these three terms from evaluated from 0 to 2. So let's do the 2 first. I guess if you wanted to, you could turn this guy into 6 over pi with a sine pi over 2x. All right, here we go. Let's plug in a 2 first. So equals, big parenthesis, 8 times 2 is 16. And then if I plug in a 2 in here, 2 minus 1 is 1. 1 to the third power is still 1 to the third power. So it's still 1. So 1 times anything is itself. So I'm going to have minus 2/3. There it is. We're not done yet, but we still got this guy. If I plug in a 2 in there, I get sine. The 2's cancel out. Sine of pi. Sine of pi is 0, guys. See, you're over here in this corner. So that's pi. So sine of pi is 0 because you're talking about the sine is a y value. The y value at that location, negative 1 comma 0. So minus 0, close parenthesis. That's the top one. Minus. Now we're doing the bottom. If I plug in a 0, I'm going to get 0. And if I plug in, so minus, let's see, negative 0 minus 1, that's negative 1. Negative 1 to the third, that's a negative. Negative times a negative is a positive, so plus 2/3. And if I plug in a 0, again, I'm going to get sine 0. And sine of 0, you're over here. The y value is 0 there again, 0. So there it is. Distribute that. So I get 16 minus 2/3 minus 2/3. This guy is 4/3, so 16 minus 4/3. And then we're going to multiply this guy by 3 over 3. I'll try to change the color there. 3 over 3. Just to get a common denominator, right? Let's see. 16, 32, 42, 54, 5, 6, 7, 48. 48. 48 minus 4. 44 over 3. So there it is, guys. That's the answer. Yay. Ms. Kyle, if you're liking this, hook it up with a thumbs up or not. You know, you're free. You can put thumbs down if you want. Letter B. Region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has an area. So this is my cross-section, guys. This is my cross-section. Yeah, it looks funky. Who knows how that looks there? But that's my cross-section. That's my area cross-section. Find the volume of the solid. Guys, to get the volume, you always integrate from A to B your area cross-section. That's how you find volume for anything. You find a common cross-section. Usually it's a shape like a square or washer or semicircle. But in this case, they're giving it to us. So this is given. So pretty much what they're trying to do is to see if you know how to integrate. That's kind of how I see this one. Integral from 0 to 2. And it's coming out of the board. This is my cross-section that's coming out. 0 to 2 of 1 over x plus 3 dx. So here we go. Antiderivative of that, that's an ln. So ln, absolute value of x plus 3, evaluated from 0 to 2. You can take out the absolute value since this is a 2 and that's a 0, so it's going to always make that positive. So ln of 5 minus ln of 3. And you can leave it like that, or you can put it together. That's ln of 5 minus ln of 3, so you can write this as ln of 5/3. And there it is, guys. We're done. Well, we're done with A and B. We're still here at C. Write, but do not evaluate, an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. Okay, so let's rotate this. I'm going to rotate this, guys. I'm going to erase this so it can help me out. Well, if it lets me erase. Okay, so let me erase this right here. Sorry, I know you guys like that. All right, so here we go. I'm rotating it 1, 2, 3, 4, 5, 6. So here's 6. I'm rotating it about that. So here we go. When I rotate it about that, let's see. That's not going to be perfect, but I'll try. And then, let's see, that's going to be like right there. And this looks like something like that. There we go. Try to make it equal distance from that line. And then something like that. And then let's see if I can fit this guy in there. So that guy's probably going to be something like, let's see, bam, bam. And so then it's going to look like, and you can't see it, but there it is. So here's my slice. I'm going to cut a slice right here where we can see it. And when I cut the slice here, so let's see. No, let's change the color because it's a bad color. Not that, you know, there's a color that's bad. There's no such thing as bad, right? So here's my slice. I'm trying to make it a little prettier. Here's my slice. And this is what's empty right there. So it's a washer. That's a dx. And we're going to add up all these infinite amount of we're going to add up all these cross sections, an infinite amount to get volume. So here we go. Remember, that's a washer, guys. So volume equals pi on the outside, integral 0 to 2. It says do not evaluate, big parenthesis, big R. All I'm doing is the distance from the axis of rotation all the way to that curve. So I'm just doing upper minus lower to figure out this distance, or to figure out a model for that distance, right? So this right here is 6. So I'm going to write 6 minus, and then this curve right here, that was the sinusoid, so that was g of x. So it goes 6 minus g of x, close it, put a square on it, minus, now it's little r. So again, little r is the distance of this one here, and I do want to call this purple. So 6 minus, and this is your parabola, that's h of x. So I'm going to go 6 minus h of x, close it squared. So big R, little r, put a dx, and there it is. Yay, we did it. And we don't have to evaluate. It says do not evaluate. All right, here we go. Let's continue. You can look up the rubric, guys. Here's the year. Just Google scoring guidelines 2019 calculus AB. and look up FRQ5, and you can see the rubric. Hopefully we got them all. I believe we did. We went over it in class after school. All right, now we got a differential equation here. So it says the depth of seawater at a location can be modeled by the function h that satisfies the differential equation. So here's my differential equation. Where h of t is measured in feet and t is measured in hours after noon. It is known that h of 0 is 4. Okay, so it looks like this is in context. It looks like this represents the depth of water at a location. H is what it does that, and then dHdt is just your rate of change, right? All right, so a portion of the slope field for the differential equations provided, sketch a solution curve y equals h of t throughout the point 0, 4. So here's 0, 4. So just follow it, guys. Pretend like these are like wind currents or water currents. Just follow. Here's how it would go. And just follow, and it looks like something like that. So there it is. Not perfect, but looks more or less okay. Yeah, all right, here we go. Letter B. Between 0 and 5, it can be shown that h of t is greater than 1. Find the value of t between 0 and 5 at which h has a critical point. Determine whether the critical point corresponds to a relative min, relative max, or neither a relative min or max of the depth of the seawater at the location. Justify your answer. Well, I can already tell you guys, look at this curve. So it looks like pretty close to 3, not quite at 3, but pretty close to 3. I'm going to have a max. So what is a critical point? A critical point is where the derivative is 0 or undefined. Der is 0 or undefined. This is just for notes. I wouldn't actually write that in an actual exam. I would just go ahead and just do it. So what I'm doing is I'm looking for where dHdt is 0. So I have dHdt there. So I would probably write, I want to know where dHdt is 0. And I'm going to put semicolon, and I'm going to set the expression equal to that. So 1/2 parenthesis, h minus 1, close it, cosine t over 2, and I'm going to set that sucker equal to 0. Now, they told me, guys, that h of t is greater than 1, so don't even think about saying that h equals 1. Because if you bring h equals 1, yeah, you'll get that as 0, but guys, look what they told you. Look. So there it is. So don't even think about making h equals 1. So the only way that you'll get a 0 is if cosine of t over 2 is 0. Now, hopefully, you covered this in pre-cal with your pre-cal teacher. You know that cosine is 0 whenever you're up here in the unit circle. That radian is pi over 2. So you know, this is from just pre-cal, that cosine of pi over 2 is equal to 0. So having said that, look at this argument here. You got t over 2. The only way that I'll get this expression equal to 0 is if t equals pi. See? You could also say t equals 3 pi over 2, but notice that you have to be between 0 and 5, and 3 pi over 2 is going to be outside of that. So t equals pi. Now, on the unit circle, look in quadrant 1. In quadrant 1, all your x values are positive, and as soon as you pass pi over 2, all your x values are negative in quadrant 2. So that's exactly what's happening here at pi. At pi, this expression, this dHdt, is changing from positive to negative. So I'm going to write at t equals pi, comma, h has a relative max since dHdt is changing from positive to negative at t equals pi. There it is. At t equals pi, h has a relative max since dHdt is changing from positive to negative at t equals pi. There it is, guys. I would say that's full credit. All right, here we go. Use separation of variables to find y equals h of t, the particular solution to the differential equation. So now they want you to find the differential equation, guys. So I'm going to put the h's with the h's and the t's with the t's. So I'm going to divide by h minus 1 to get it to move to the left. So I have dh over h minus 1 equals, and then times dt. So I have 1/2 cosine t over 2 dt. We look good. Everything looks good here. I don't see any issues. All right, here we go. We're going to integrate. To get rid of the differentials, the dh and the dt. When you do that, notice I have h minus 1. It's a linear expression in the denominator. So this is going to be ln. There's no limits, so put absolute value. H minus 1, close it, equals. And then antiderivative, so here it is. I put a half. Antiderivative of cosine is sine. So I'm going to make some room there. Sine of t over 2. Remember, guys, this is the same as half t. And then I'm taking an antiderivative, not a derivative. So I got to multiply this by the reciprocal of half. The reciprocal of half is 2, so times 2. There it is. And then I'm going to put the plus c there. So there it is, guys. The 1/2 and the 2 cancel out. I'm going to plug in this. The 0 is a t and the 4 is an h. 0, 4. So t, h. All right, here we go. ln, absolute value, 4 minus 1, close it, equals sine of 0 plus c, because I'm just plugging in the 0 in there. 0 over 2 is 0. Sine of 0 is 0, guys. And 4 minus 1 is 3. So c equals ln of 3. So there it is. I'm going to plug that in right here. So here's what I have. ln, absolute value of h minus 1, equals sine of t over 2 plus ln of 3. We're still good. I don't see any issues. Sorry, guys. All right, let's go ahead and bring down, get rid of those ln's. Well, get rid of this ln, right? So I'm going to do that by saying e and e. So I'm going to write e caret. All this is e. And here we go, guys. E and ln cancel each other out. I have absolute value of h minus 1, close it, equals e to the sine of t over 2 plus ln of 3. Now remember, law of exponents, this is equivalent, h minus 1 equals e to the sine t over 2 times e to the ln of 3. And this right here that I'm circling, that's just 3, guys. And now I can get rid of the absolute value by putting plus minus. So I'm going to write h minus 1 equals plus minus 3e to the sine t over 2, close it. And I'm going to move the 1. H of t equals plus minus 3e to the sine of t over 2 plus 1. Now remember, when I plug in a 0, I better get a 4. So you have to choose a positive one, because if you plug in a 0, you're going to get e to the 0, which is 1. 1 times 3 is 3, so you want that to be positive, and then 3 plus 1 is 4. So there it is. H of t equals a positive 3e to the sine t over 2 plus 1. I don't see any issues. I think we're good. I think we covered everything, guys. If this helped, hook it up with a thumbs up. I hope you guys are ready for tomorrow. Let me know if there's anything you want me to cover. I'm probably going to take a short nap in a little bit because I'm pretty tired. And, whenever I wake up, if I wake up at midnight, then so be it. And if you have questions, I'll see if I can answer them before we test at midnight or, whenever. All right. See you guys later. Bye-bye.